Hey everybody, it's the Good Math Guys, Mike and Sean. In this episode, we have another Jacob-Trachtenberg method for multiplying multi-digit numbers by 12. Really cool method for you that doesn't even really involve any paper pencil. When you get good at this one, it can all be done in your head. And the bonus is, you don't even need to look at the 12 when you're doing this. You just need to focus on the multiplicand and follow the directions on the side of the screen here, and you can find the product without even messing with the 12. If you don't believe me, stay tuned.
Hi everybody, this is the Good Math Guys, Mike and Sean back at you again. Today we're going to explore another bonus multiplication problem or strategy that was created by Jacob-Trachtenberg again. And it's called multiply by 12. Now, for this strategy, all we're going to do is manipulate the numbers of the multiplicand. The multiplier 12 has no bearing on our completing the problem at all. So what I want to do here is start out with the traditional way, the traditional partial product way, so that we can see the patterns that Trachtenberg saw when he was developing his mental way for doing multiplying numbers by 12. So let's consider this problem, for example, 312 times 12. Now, doing traditional partial product, we're going to multiply 1s times 1s, 2 times 2 is 4, 2 times 1 is 2, 2 times 3 is 6. And then to get the second partial product here, we're going to multiply the 10 times the 2, which is 20. And then 1 times 1 is 1, 1 times 3 is 3. And what we would do is shift into adding these two partial products together to get the complete product, 4, 4, 7, 3. Now, here's what Trachtenberg saw when he was developing his mental method for doing anything times 12. So let's write the problem again, 312 times 12. Now, remember, I said we're not going to consider this 12 at all. All of the number manipulations will occur in the multiplicand only. So what we want to do, in terms of what Trachtenberg saw here, in step number 1, is we want to double ones. So 2 doubles to 4. That's that 4 that you're seeing right there. Next step would be to double tens, so we're going to double this 1 to 2 and add the neighbor to the right. So double 1 equals 2 plus 2 equals 4. Here, Trachtenberg knew that that was going to occur all the time because 2 to 4. Then what we're going to do in the next step is double the 3 and add the neighbor to the right. So 3 doubles to 6 plus the neighbor to the right 1 is 7. We're going to record a 7. And again, Trachtenberg saw that here with the 6 and the 1 equaling 7. That was something that times 12 was going to occur all the time. And the final step now would be to simply bring down the 3, which gives us the same product, 3,744. Just for the heck of it, let's use digit root or digit sums to check to see whether or not this multiplication was right. Now, I'm going to do a lot of the digit summing in my head, so if you don't understand what's going on, you want to back up into our playlist and check out finding digit roots, and then finding digit roots by casting out 9, and then see how we use that to check a multiplication problem. So a lot of what I'm going to do here now is in my head. So finding the digit root for 312, 3 plus 1 is 4 plus 2 is 6. Digit root there is 6. Digit root for 12 is 1 plus 2 is 3. We're doing a multiplication problem, so we multiply these digit roots. 3 times 6 is 18. 18 is not a digit. 1 plus 8 is 9. So our magic number here is a 9. If we can generate a 9 for a digit root of 3,744, we did not make a mistake, and we consider that it's error-free. So in this case, 4 plus 4 is 8, plus 7 is 15, plus 3 is 18. And sure enough, 1 plus 8 equals 9. Because these two 9s match, we can consider that there's no error in our multiplication. Let's try another one, strictly by multiply by 9s. We're not going to do the traditional model anymore. Let's try 124 times 12. And remember again, the only number that gets manipulated is the multiplicand. So what we want to do here is double the 1's digit, 4 doubles to an 8. And then we're going to double this digit, 2 doubles to a 4, and add the neighbor to the right. So 2 doubles 4, plus 4 is another 8. Then what we're going to do is double this digit. 1 doubles to 2, plus the neighbor to the right is 4, and then simply bring down the 1. So we think 124 times 12 is 1,488. Let's use digit roots to check. 1 plus 2 is 3, plus 4 is 7, so the digit root for 124 is 7. Digit root for 12 again is 3. We're doing a multiplication problem. 3 times 7 is 21. 21 is not a digit. 2 plus 1 is 3. So our magic number here is a 3. I get a 3 for a digit root for 1,488. We can consider we haven't made any mistakes. So double 8, 16, plus 4, 20, plus 1 is 21. 2 plus 1 is 3. Our digit roots match, therefore we can consider that 124 times 12 indeed is 1,488. Let's try another one. How about 223 times 12? Again, the only thing that gets manipulated is the digits of the multiplicand. So step number 1, double the 1's. So 3 doubles to 6. Step number 2, double the 2 to a 4 and add the neighbor to the right, gives us a 7. Step 3, double the 2 to a 4, add the neighbor to the right, gives us a 6. Last step, bring down the 2. So we think that 223 times 12 is equal to 2,676. Let's check it using digit roots. 2 and 2 is 4, plus 3 is 7, times 3, 21. Looks like we're going to get a 3 again. And here we have 6 and 7 is 13, plus 6 is 19, plus 2 is 21. So sure enough, the 2 3's match. We can consider that there's no mistake in this multiplication. Let's try one more where we're going to have to regroup. How about 678 times 12? And once again, the only digits we're going to manipulate are the digits of the multiplicand. So the first thing that we want to do now is double 1. So 8 doubles to 16. We're going to record the 6, but we're going to hold 1 in our heads. Next step, double the 7 to 14. Add the neighbor to the right, which is 22. Add the 1 that we're holding in our head, which is 23. And we're going to hold this time 2 in our heads. Next step, double 6, 12. Add the neighbor to the right, 7. 12 and 7 gives us 19, plus the 2 that are in my head gives me 21. Record the 1, hold the 2 in our head. Now instead of bringing down the 6, we're going to bring down the 6 plus the 2, which is 8. So we think that 678 is 8,136. Again, let's use our digit roots to try to see if we have made a mistake or not. So 6 and 7 is 13, plus 8 is 21. 2 and 1 equals 3. 1 and 2 is 3, so we know the digit root there is 3. We're doing a multiplication problem, so 3 times 3 is 9. Here our magic number is 9. So if I get a 9 out of this, we're good to go. Looking at this now, I can cast out 9s, and boy, oh boy, it looks like there's 2 of them that we can say goodbye to, 3 and 6, and 8 and 1, which is going to give us a digit root of 0. Now, guess what? I can do the same thing here. Cast away this 9, and what I get is a digit root of 0. The 2 zeros match. Wham bam, Uncle Sam, we can consider that we have not made any mistake in the multiplication. That was Trachtenberg's version of multiplying any number times 12. Super easy. And again, remember, as Sean and or I discussed in the first Trachtenberg video, these were really designed for kids who were having a terrible time or struggling with mathematics at the elementary level. So being that you can see really how easy it is, all the kids really have to do is plug into the little bit of logic and seeing the patterns like Trachtenberg did when we did this first model over here. For now, that's it for this program. There is no more, so until the next time, this is the Good Math Guys saying bye-bye.